So if you start and make some announcement, then we can I will get that chair. So I will get that chair.
No. Just be careful. Yeah, let's get the projector.
This is problematic.
This wire is problematic. Yeah. Are we on? Later. Okay, guys, let's start. Can I see the audience? Hello and welcome to Chai and Why. Sorry for this little glitch. There's some power cable got pulled out and we lost the projector. You'll get this. We'll get back there in a minute. I should share your PPT. I should first go full screen and then go to Zoom and share screen. This one. Okay. So a very warm welcome to Chai and Why, both here in Ruparel College as well as to our online audience on YouTube. Today we're going to play some games with maths, and these will all lead us to finally making magic squares, and we'll have some other fun. But there is actually two parallel things happening. The universe outside is going to keep working as it does. The sun's going to go over our head as it does. Today is a very special day in Mumbai. At around 12:35, the sun will be vertically overhead, and hopefully there will be no shadow of a vertical object. We've kept some sticks in the lawn outside. We will watch that. At 12:30, we'll take a break and go outside, and we can stand and see if we also cast a shadow or not. And we can mark also on a paper how the shadow changes with time. So we have some volunteers looking at shadows as well. But let me introduce Ravi Sinha. Ravi, can you somehow squeeze in so you can be seen here? Yeah, there's Ravi. Hi, Ravi. So Ravi is from the Homi Bhabha Center for Science Education, where he is a scientific officer working in the learning sciences lab. Is that correct? Yeah. Yes. Ravi came from Jharkhand. Jharkhand, yes, he's from Jharkhand. Then he went to Delhi. Yeah. Delhi, did his bachelor's there in engineering, and then eventually came in Mumbai and joined us. And Ravi likes to have fun with lots and lots of things. Mathematical games being one of them. So we're going to keep this informal, keep asking questions. If you're on YouTube, please put your questions in the chat so we can follow them. Can you turn your laptop on so I can get on YouTube and see the questions? Yeah. Okay. We've had some last minute laptop change. So usually I'm the one who looks at YouTube, but I don't have our laptop is being used for this right now. So with that, it's going to be over to Ravi in a bit. And just in case you're wondering what happens, 2 weeks later, May has 5 Sundays. On the 5th Sunday of May, we'll be back here in Ruparel College only. We still don't have any permissions at the school where we usually are. So we'll be back here. And we will be looking at, again, games, but from computer science, from the area of graphs and networks. Okay, so we'll see what graphs and networks are in computer science, and we'll play some games for that as well. And the last of our summer specials will be the first Sunday of June at Prithvi, where we will be doing hands-on experiments in biology. So that's what's up. So over to you, Ravi, with maths games. And I hope all of you have a pen and a paper, a pencil and a paper to scribble on. That will be very useful. And Ravi, at some point before all the ice melts, when you feel like taking a break, we have some cooking starters.
Sure.
Okay. And please be loud because there's no mic for the people here. And
yeah, if you want, like it's signed in my account. So
that's fine. That's fine. I just want to say that can you hear us?
So I want to share the other screen. I want to start with the.
Okay. Yeah, wait. You want the other tab? You can kill this tab. Remove that green bar.
This one I can.
Yeah, is that tab you want? Exactly. No, but why did you should play this one? Wait, remove. Okay, one second.
This Windows not used to.
Okay. Here you are. This is index. Do you want the other one?
Yeah, game one.
Okay, so this. Okay, now you're gonna share screen.
Yeah. So I go to Zoom.
Oh. It's already in Zoom.
Oh, it's already reached. So. Okay, so good morning, everyone. I hope the screen is visible to and clear. So we'll kickstart with a small game. What I want you all to find out is can you see three numbers which sums up to 45? So can I get some responses? So 21. So it's 38. Yeah, only three numbers. Yeah. 14, 15, 16. So yeah, it's 45. What about the other six? In the other six, can you see three more combination, which 22, 8 and 15, that is also 45, but it was 15 we already selected in the previous combination. So any more such combination, can you think? Can you be a little loud? 22, 9 and 14, that is also 45. (23, 8, 14), that is also 45. So any more such combination? Okay, maybe I'll make it a little difficult. I will reset it. So I'm just shuffling the numbers. (23, 7, 15). So there's also 45. So yeah, so we can see that there are a couple of different combinations in this 9 by 9, 3 by 3 grid, which sums up to 45. So with this, we'll quickly move on to this game, and I'm entering few numbers. So I need 2 volunteers for it. Okay, so the numbers are 1, 2, 3, 8, 9, 10, and 15, 16, 17. And the target sum which we have to achieve is 27. So we just looked at some numbers using, and the sum was 45, but in this case, we'll play with 27. So I'll just quickly give a demo. So if the first player makes the move, so you all have played tic-tac-toe, right? So tic-tac-toe may like we either have to make cross or 0. So in this case, the player 1 make the first move, then the player 2 will have to choose the numbers among the remaining numbers, and the one like who will choose the third number in the third move, if he's able to get the 27, then he wins. So for instance, I can choose maybe 8. So you can see that player 1 chooses 8, then player 2 can choose 9, and in this case we can see that 8, 9, and 10 will 27. So is of player 1, and he's able to they are able to achieve 27. So is the game rules clear? So okay, so I need 2 volunteers and maybe like some so I'll reset it, and yeah.
Okay, so I think you should just explain the rules of the game again.
Okay. Okay, so it's just like, so we need 2 volunteers for it. And since new people have joined, so again, I'm going to repeat the rules. So for instance, we all have played tic-tac-toe, and the objective of this game is to either make the row, column, or the diagonal as 27. And you have to block each other's move. So for instance, if player 1 starts with 8 on the top left, and player 2 makes the move as 9 in this column, then player 1 can again write 10 here, and we can see that the sum is 27, hence it's green.
So player 2 must try to block player 1, that we cannot put 3 in a row and make 17.
Yeah.
Or 3 in a column or 3 diagonal. Okay? Okay, who's going to play?
Okay, so second volunteer.
Second volunteer? You play? Okay, good. Excellent. Sit there, no problem. Okay, who's player 1? You're player 1. Okay, player 1, go ahead. Decide a square, decide a number.
Number 17. At this place? Okay.
So 17 is chosen, and you see 17 has now disappeared from the list below.
Yeah, it's not here.
17 is chosen. So now you choose a number, you can put it anywhere you want, but make sure that we cannot put another number and make it 17. No, 27.
27.
27.
Middle one, 10. Okay.
Middle one, 10. Okay, very good. Very good.
Since we have to have 3 numbers, so it's although it's 27, but we need to have 3 numbers.
You can't put another. You can't put 0 is not a number.
Yeah.
So 0 is not in that list.
First row, second row.
Above 10. Above the 10. Yeah.
9. One, which place? This. Okay, top right. Yeah, so we can see that it's 27 and player 1 wins. So any round 2?
Yeah, below 10 game.
No, but
okay, can you repeat the rules online? Online audience must be repeated.
Oh, okay. So so as we have seen in this, I will just use this example as a way to like explain the rules. So we have seen that we had 2 players. So player 1 chose 17 in the first move, and we can see the player 1's move here as 17. So the objective of the game is to make alternate moves and to reach the sum of 27 in combination of 3 numbers. So either you can block the 27 in row, column, or in diagonal. So in this case, we saw that player 1 is able to block the first row with the sum of 27. So
let's play this again. I think then we'll have more.
Yeah. Okay. Okay. Let's play the second round.
Okay. Who's playing the second round? Okay. One here. Someone this side. Second round. Okay. Great. Great. She's gonna play. Excellent. Okay. Choose a number and choose a square you want to put in.
10 in the middle.
10 in the middle. Okay, 10 in the middle.
So we all can see that player 1 chose 10 in the middle, and this is being displayed here. Okay, player 2. 17 here. Okay. So we have 17 in the first row, first column.
Okay, now player 1, be careful. You have to put it somewhere where player 2 cannot put another number and make it 27.
Third row, this one.
Careful, okay. Think. Diagonals are also allowed, by the way.
Yeah.
Your neighbors can help, it's okay.
Yeah, you all can discuss. So basically, if we have to choose a move for player 1, third row, third column, this place. Yeah, okay.
1.
So far it looks
okay. So far it looks good. Now it is back to player 2. You can put something so that she cannot add a number and make it 27.
First row.
First row. Second column.
3. Okay. So we don't have 7 here. So yeah. So that was a. But what number is needed here to make it 27? 14. 14 is also not there. So this was a good move.
So this was a good move because 17 plus 3 is 20. You would need 14 to make it
7
no, you need 7 to make it 27, but there is no 7. So they can't put it there. And 3 and 10 is 13. You need 14 to make it 27, and there's no 14. Okay, and because it's in the middle column, there's no diagonal involved in this. Okay, so now it's back to you. Back to you.
So play one. Well. So just like tic-tac-toe, if none of the players is able to make the 2. Are you sure?
Are you sure? 2. Your neighbors don't think it's a good move.
8.
8. Okay.
Are you sure? So neighbors can help. So think of all the possibilities, like think of diagonal, the column, and the row. 16. Same place.
16. Okay, good.
Okay. Back to player 1. So we have to make the sum as 27. I'm again repeating it for the online audience, and we can see the current state of the board between player 1 and player 2. So we are left with 2, 8, 9, and 15 as the numbers, and either we can make it row-wise diagonal or column-wise as 27. Third row, first column, 15.
15.
Okay, we have 15.
Okay, back to you now. Can you make 27 somehow?
So we're not seeing any green highlight. So far it's going good. Okay, player 1. So we're left with.
Let's call them team 1. It's not player 1 anymore. It's like team 1. Team 1.
Okay, team 1. Nine where? Below 10.
10 and 9.
Okay, 9.
Okay.
So team 2. Okay, and then this would be 8, and it's a draw.
And it's a draw. Okay.
So that was it.
So now at least you figured out the rules of the game. Right?
Yeah.
You have to block other people, and you have to block other people thinking about their next, not about the done.
Yeah. At the same time, making sure that you get 27. So do you all want to play one more round, but a little bit fast? So we can maybe have a timer like 10 seconds, something like that. Okay, you all understood. So again, I'm clearing it.
Okay, so whenever the next team says they need enough time, okay, you have to turn up. Okay.
Okay,
right.
let's.
So who's playing on this side? You're playing at the back. Okay, from this side. And the other side, you can take help from your neighbor. That's enough. Somewhere here. Okay, she's going to play in that corner.
Okay.
Excellent.
So who wants to be team 1?
Team 1.
Team 1 and team 2. We'll keep the thing same. Okay. 1 in the middle. Okay. You all can have the timer. I mean, like this. Over 1. 15 here. Okay. So second row, third column, 15. So back to team 1. So this is the last round. We'll go back to the presentation after this. Yeah. 8 where? this place. First row, third at this place. Yeah. Third row, first column, 8. Okay. So back to, yeah, player 2, team 2. So I think seems like everyone is thinking. Team 2. 2 ever 1. Okay.
Okay. Team 1.
Team 1.
Your time has started. Go ahead. Need to put some pressure on them. What time they are?
10. 16 ever 15. Okay. Done. 9 here. Nice. So I hope you all had fun. We'll come back to this game in the end. So there is a loophole in this game. If you are able to figure out, then I would urge you to like keep it with yourself, and we'll discuss that towards the end. Okay. But we'll come back to the topic of the today's presentation, which is around magic square. So let me reshare the screen for the Zoom audience. Okay.
New share. What do you want to share?
Slides. Yeah. Okay. Sounds good. Okay. So we started with this grid, right? And this was also in the poster which was circulated. So do you all recall this grid? So what do you think is special about this grid? So anyone has heard of magic square before? Can I just hide the hand raise so that you get an idea of like okay, 2 people.
आपको magic square सुना है कभी? नहीं. Okay, they have not heard of it.
Okay. So do you want to maybe yeah. Sum of all. Okay. Do you think this is a magic square?
Is this a magic square? Can you add up the rows, add up the columns, add up the diagonals? Are they all same? If you add up the rows, all the rows, 3 rows, 3 diagonals, 2 diagonals and the 3 columns, they should all be the same number.
So
is this a magic square?
So the first row is 22, 9, 14 is 45. If you add 7, 15 and 23, it's also okay. So it's also 45. And the bottom row is also 45. What about the columns? 45, 45, 45. There are 2 diagonals also. This one and this one. So these are also 45. So this is an example of a magic square. Do you see these patterns familiar? Like, have you seen this number in some? Do these numbers look familiar? I'll make it easy for all of you.
ऐसे number आपने कहाँ पे देखा हो? Where have you seen these numbers?
So let me rearrange this grid. So what I'll do, I will make another grid and I will start rearranging these numbers in ascending order from smaller to bigger number. Okay. So we'll start with 7, 7, 8, 9, 14, 15, 16, 21, 22, 23. Now this looks familiar, right? Where you have seen it? in calendar. So this is last month's calendar. And we can see that this is the same grid, right? So apparently what we did, we took this 3 by 3 grid, we rearranged those numbers such that we form a magic square. So in this session, I'm just going to talk about how we can do that, how we can like take this grid and how we can like convert it into a magic square. So that's one part of the session. So is the objective, I mean, is the this thing clear? Okay, but is it only something special about this grid which makes it a magic square, or we can have so we rearrange this, we got a magic square, or so we have multiple grids, right? So can we take any 3 by 3 grid and convert that into a magic square? What do you think?
So just repeat the question again for the online audience also.
Okay.
Can any 3 by 3 grid on this period?
Yeah. So can any so is it a property of only this 3 by 3 grid which was making it special to form a magic square, or we can take any of these 3 by 3 grid so that it can also be rearranged in a way so that we can get a magic square? So people who are thinking yes, they raise the hand, and if you're unsure about it, you can choose to like. So what do you all think? So maybe 5, 6, 7, 12, 13, 14, 19, 20, 21. So can these be rearranged to form a magic square? What do you all think? Yes? Just.
How many yeses?
Okay. Maybe. Maybe. No. Okay. So we have like mixed polling here. So we'll get back to this question like later. So I think you will be able to figure out yourself whether we'll be able to convert this into magic square or not. But let's focus on the simplest one. 1, 2, 3, 8, 9, 10, 15, 16, 17. And use this as an example to make this a magic square. The first question arises that, okay, what would be our strategy? So can we just take any of these numbers and start like rearranging it into a grid? What do you think? Like, would that be a good strategy? Like randomly doing hit and trial and then figuring out. Why do you think it's not a good strategy? Okay, so if you can see that in the first place, you can have any of the 9 numbers, right? In the second place, out of those 9, you will have in the second place, any of the 8 numbers can come. In the third place, any of the 7 numbers can come. So if you keep doing this, you will actually have 9 factorial combination to rearrange this grid, which amounts to around 3.5 lakhs combinations. So there are more than 3.5 lakhs ways of rearranging these numbers in this grid. And out of those, only 8 combinations are there, which will form magic square. So right now I'm saying 8, but this number will change to 1. And I will talk about why it is only 1. And there is something here like including rotation reflection. So we'll see that later. But so far the goal is clear, right? And why we cannot do hit and trial, that is also clear. Okay, so let's then take this grid, and the first question is, what should be the first question? I think that should be the first question. Yeah. Perfect. So the first question we should ask is, what should be that magic constant, right? So what's it? Yeah. Okay. So with the data with the information which is there on the screen, can we figure out like what should be the magic constant?
So what will it add up to this way, that way? We want it to add up to the same number. What is that number?
20.
Q. If you say your answer, tell us why.
And how? Okay, so we need a number such that all the rows will be same, right? So these dot should cover all the 9 numbers, rearranged in some fashion. And we also know that individually each row will amount to the same number, which is R in this case. So we can take the sum of all the numbers. That is what I think we got the answer. And then we can have 1/3 of it, right? That would give us the magic constant. Take some time. Like if you have question, then I think we can again discuss this. So adding all the numbers and taking 1/3 should give us the magic constant, irrespective of what 9 numbers you choose. Okay, what would that be in this case? It will be 27. Any confusion in this step? So the first goal was what should be the magic constant? We are able to figure out that from the information which was already in the screen. So we took the sum and then we divided by 3 and we got the magic constant. Okay. So now we need to rearrange these numbers in such a way that row wise, column wise and diagonal wise it should be 27. So we have narrowed down our problem space. We still need to do a little bit of hit and trial, but now it's no more like 3.5 lakhs combination. So what should be the next question? The next question should be to figure out all the triplets which will amount to 27. So right, all the 3 number combination you have to figure out from these numbers which will amount to 27, and then we'll think of a way to fill that in the grid. And hopefully, I think we'll be able to solve the magic square.
Okay. Can you repeat this in an easier language for somebody who was in grade 8? Actually, very, very yeah. So the kids listening to us, the people online were listening, and they said, "Can you please explain this slightly easier?"
Okay.
Can you just explain this idea of how you came to 1/3 and how you got the idea of doing this 3 by 5?
Okay, so I'll try to like attempt once again. So bear with me, like it will be a repetition. So as you can see on the left side, so we have all these 9 numbers, right? 1, 2, 3, 8, 9, 10, 15, 16, 17. So we can take a sum of all these 9 numbers and the sum is amounting to 81. So that we can do it for any of the 9 numbers combination. Now on the right.
So whichever way you put the 9 numbers, it will always be 81. The total has to be 81.
Total has to be 81. Exactly.
So it doesn't matter how we put the numbers. Any way you arrange it, the total has to be
81. That we know because we have all the 9 numbers. Okay. Now the challenge before us is that, and we also know that we want to make this as a magic square. So, and what does that mean? That would mean that row sum would be same. The row sum would be the same. So the first row, second row, and the third row sum would be the same. And while doing the row sum, just observe another thing, right? We are taking 3 numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are only these are the same 9 numbers. So we are exhausting all the 9 numbers to rearrange on the right hand side grid such that it becomes a magic square. And we also know that each row would be same. So we know the total sum. And we know that it has to be like 1, and we know that individual row is equal. So that's why we can say that
3 parts must add up to 81.
Yes.
And we know that all the parts are the 3 of the same sum.
Yes.
So it has to be 1/3 of 81.
It has to be 1/3 of 81. Yeah.
Okay. All right. I hope that's clearer. Okay. Go ahead.
Go ahead. So that's how we are able to get 27 because 81 by 3 is 27. And now the task is relatively simpler because we need to figure out a way to rearrange these numbers. Okay. So next task is to figure out all the triplets, which sums up to 27. And I think this we already did, right? The game 1. Do you all recall the game 1? We had like these numbers 1, 2, 3, 8, 9, 10, 15, 16, 17. And the numbers were different. We were doing it with 45. But it's similar, so hopefully you will be able to figure out. It was with 27.
Remember, D1, D2, you're adding up to 27. You have to prevent the third number such that it doesn't become 27. But here you want to make it 27. It's the same game, slightly different now.
So maybe I will pause here and I'll give some time for you all to figure this out. Why don't you all come up with all the triplets which will amount to 27, and it has to be unique. Let's wait for some minutes.
Okay, and by the way, the in-person audience over here, if you're taking a break, you might just want to look outside. There's a stick over there, and just see where the shadow of the stick is. It's on one side of the stick right now. It's about 11:35. Just look at the stick and the shadow on the white paper. Then you can see the shadow of the stick. We look at it at 12 o'clock. We look at it at 12:30 again. Okay. Yeah, you can go outside. Okay, and keep thinking of 3 numbers from this set which will add up to 27.
Yep.
Different triplets, so different combinations of 3 numbers that become 27.
Okay. So for the online audience, you can write down your answer in the chat. So the task here is to figure out all the 3 number combination, which sums up to 27. And after that, we'll proceed with the next steps. And I hope it is clear why we are looking for numbers which sums up to 27.
Okay, so do we have some answers? Are we getting some triplets? Yeah. Okay. 16, 10, 1.
Should I show one example? Would that be helpful? Okay, so this was a task, right? So if we look at if we choose 1 and 2, what number we need as a third number to make the sum as 27? 24, right? And we don't have 24 here. So this cannot be chosen as one of the combination. Then we can look at 1 and 3. We need 23. Again, 23 is not there, so we won't take this. Then we look at 1 and 8. We need 18. Is 18 there? 18 is not there. Again, we'll discard this combination. We look at 1 and 9. 17. So we have 17. So this becomes one of the combination. I put it on the right hand side of the grid. So likewise, you have to figure out all the other remaining combination, which will sum up to 27. Hopefully now it will be more clear. 2, 15, 17. Why don't you write it down and then we can match it, because I have these on the slides. So once I will scroll it down, then we can just check whether we got all the combination or not. So how many different combination you can figure out?
Okay, so we're getting online answers as well. There's 8, 9, 10.
8, 9, 10.
1, 16, 10.
1, 16, 10. Yes. 9, 1, 9, 1, 17. Which is there? Yeah. Which is same as 1, 9, 17.
17, 8, 2.
17, 8, 2. Sorry. 16, 9, and 2. Yes, that would also be 27. 16, 3, and 8. Would that be 27? Yes. 24 plus 3, 27. 2, 10, and 15. That is also 27. So, okay, so we have a lot of numbers. Now I would urge you to just compile all your answers, and can you let me know how many different combinations you could find? You could find. Is it 1, 2, 3, 4, 5, 10? How many combinations you could figure out? So we listened to some answers from all the audience, including the online one. Now, can you all just compile it to figure out how many different answers you had in your paper? For the online audience, you can maybe use semicolon to separate your answers and put a compiled reply. So all the 3 number combination separated by semicolon, you can paste it on the chat, and yeah, that is the exercise which we are doing right now. Is it? I hope it is not getting boring. So this is the only part where we need hit and trial. But again, you can do some systematic way to like reach all the combination. But should we look at the answers? Okay. So 19, 17, 17, 19 and 9, 17, 1 all are same. So that so you need to figure out 3 number combination which are unique. And if you are able to compile those, then we can proceed to the next steps. Should we look at the, or maybe 1 minute more, 1 or 2 minutes? What do you think? Should we wait? Should we proceed? Okay. Then let's do the same thing. So in the slide, so this is one way of like figuring out all the combination. You can like systematically fix one number, and then you can choose the second and third. And once you look at all the options, you can start with 2 and then repeat the same steps. And hopefully, so you can match all the combination on the right. If you are able to figure out. So we got 1, 2, 3, 4, 5, 6, 7, 8. And it has to be 8, right? Why? 3, 3 and 2. Yeah. So so we have all the 8 combination with us. And the next question is, so if we take one of the combination, which is 1, 9, 17, the next question is to figure out how we should place it on the grid. Because we are like 8 of these combination here, and we are unsure about how do we go about placing it. So the hint for this thing is on the screen itself. Just look at the geometric properties of this grid, and you should be able to figure out like which number to place where, which combination to place where, or which number to place where. So maybe I will give some minutes for you to think. It's a very beautiful pattern here.
Which number appears 4 times?
Which numbers appear 4 times? 9. So what would that give us the?
Okay, so which numbers appear how many times? Why don't you look at this? Look at which numbers in this set
Appears how many times?
And then look at the square and see which places you might want to put such numbers.
All the corner numbers? Is it 4 times or 3 times all the corner numbers? Okay, so we'll come back to it, but maybe some people are still thinking. So maybe like just hold on to your thought for a minute. We'll get back to that like within a minute. Yeah, so right now we are figuring out whether we should place it in a row wise, column wise, or diagonal wise. And yeah. And the hint is like which numbers appears how many times, and you have to look at the properties, geometric properties of the grid to figure out the next move. So a lot of discussions are going on, so maybe I will give a few minutes more. Is it confusing so far? Okay. Any part you were not able to figure out, or any question at this point of time? Shall we proceed? Should we proceed? Yes. Okay. So, okay, let's look at the frequency of each number. How many times they are appearing in each of the combination. So, okay, but before that, we'll look at the properties of the grid. So, as we got some replies that the the corner number has to appear in three different triplets. And how many corner numbers we have? 4 of these, right? So 4 numbers would be there, which will appear in three different triplets. Let's look at the middle number, like not the center number, but the corner middle number. Yeah. So it is appearing in the 2 combination, and again we have 4 different numbers, and finally we are left with the center number, which is appearing in 4 different combination. And so this one is 3, this one is 2, and this one is 4. And now we have to figure out the frequency of each number. So 1 is appearing twice. So in this you all can do, right? So I'll just fast forward it. 2 is appearing 3 times. 3 is appearing 2 times. 8 is appearing 2, 8, 17, 3, 8, 16, and 8, 9, and 10. So again 3 times. 9 is appearing 4 times. So we got our center number, right? Because there is only one number which is appearing 4 times, right? So 9 has to go in the center. 10, 3, 15, 2. Okay, I will just fast forward it. And now you can see the color code, and you can take some time. Just look at the pattern, and this would give us the clue for the next step.
So I think you should ask, is it clear why 9 is in the center? Okay.
Okay.
So if it is clear, because 9 comes in 4 of these sets, and the center one comes in 4 different triplets. Okay. Yep. So now look at the blue ones and the purple ones. You can see which ones come 3 times, which one comes 2 times. Look at these numbers, see which numbers you want to put in, and then hopefully you'll be able to solve this.
So do you want to now fill the grid, because we have enough clue for us to solve the magic square? And we didn't use any formula, or we didn't memorize anything, right? It was quite intuitive and logical. So I'll give some time to like fill the grid. So 9 is there.
So who has filled it?
Okay. So if you have completed your magic square, you can just raise your hand so that I get a, okay, all the people. So we can start with any of the number. We can start with the odd numbers. So 1 and 17 can go here, and then we have 3 and 15, right? So 3, 15, you can place it in the middle row, in the middle column, and then you can take any of the even numbers, 2, 8, 10 and 16. So I'm choosing with 2. If you choose 2, then automatically the other 3 numbers are locked, right? Because you have to make the sum as 27. So 2, 9, and which number will make 27? 16. 2, 17, and 8, and 2, 15, and 10. Can you now check whether this is a magic square? So row wise we are getting 27. column wise, are we getting 27? Hopefully we are getting 27. And diagonal wise also, hopefully we are getting 27. So is this so far clear?
But some of you have different solutions, no? So let's look. Let's see.
Yeah, remember like what was the out of 3.5 around 3.5 lakhs, like how many combinations was mentioned? 8. So some of you may have got a different combination, right? Which is different from this. Maybe can we so how do we now, the next question is like how many different combination you can generate from this one solution which you have. So what would you do to generate more combination? You will reflect it. We are getting okay. What does it mean to like reflect it? Okay. Okay. So reflection, basically you put a mirror and you take the reflection, you write the numbers on the grid. Anything else we can do? We can rotate it. So now you remember the rotation reflection part, which was written in the beginning. 8 combinations, including reflection and rotation. So let's start with the rotation part. So we take the same number 16, 3, 8, 1, 9, 17, and 10, 15, 2, and we rotate it. So let's observe the first row and we give a 90-degree rotation. And you can again fill the other numbers. We get the second second combination. It is also a magic square. How many times you can rotate? So one more time, we'll get this. We'll get this. Okay. At this point, I'll want you to like actually take a small piece of paper. Just write down the 16, 3, 8, 1, 9, 17, and 10, 15, 2 on top of it, and also behind it. So can you take a small piece of paper and maybe write the first combination 10, 16, 3, 8, 1, 9, 17, and 10, 15, 2. I think this was the online audience also, because it, okay, I think I jumped to the, it might be easier to visualize, because if you make a grid and if you rotate it, so if you have a piece of paper, you can just write 16, 3, 8, 1, 9, 17, and 10, 15, 2 on the front side, and on the back side also like write the same number. So behind 16 you write 16, behind 3 you write 3, and on the back side, front side you write 8, and the back side should also be 8. I may have one with me, so it's optional. If you want to like do, you can do it. Otherwise, this is something which you can also try at home. Okay, so we had some papers. Can you now flip it? So this one, if you flip it, okay. Should I also? I will also make one. Okay. Yes. So first I just wrote the, okay, I'll just make a grid also. Otherwise, okay. So I just took a small piece of square paper and I wrote this 16, 3, 8, 1, 9, 17, and 10, 15, 2. The next exercise is to like write 16 behind the number 16. So this will take a little bit of work. So behind 16 should be 16. So here it is 3. The behind should also be 3 on the back side. This is 8. So the back side should also be 8. 1, 9, 17.
dark and hold it for some time because it's a very small tile.
Oh, okay.
Share the rest. The CEO is very small. So if you want to show it to the thing, share.
Okay. Is it now?
Just unshare. Just unshare and just go for the escape.
Stop sharing.
Yeah.
Okay.
So yeah, just explain for the online.
Okay. So I hope this grid is visible. So I just wrote this 16, 3, 8, 1, 9, 17, and 10, 15 to in this piece of paper, and on the back side also. So behind 16, if you see, I have written like 16. So behind each individual number, you have to write down the same number so that you will get this grid. Okay. So once you are done with this, it will be easier for you to like follow the slides, which is coming. Okay. So again, I will share the slides. Yeah. So the rotation is pretty simple that we all saw, right? So I will skip that part. Now the reflection part. So take a, like however you rotate, like it will depend on that. So if you take a flip this, you will get on the back side this new grid, and you can rotate that also 4 times, right? So you reflect one and rotate thrice, or you take individual reflection of each grid. That will also reach the same combination. We are just doing this transformation, rotation, reflection. Okay, but the interesting thing is, this is the same magic square, right? Because behind 16, it's 16. Behind 3, front is 3, back is 3. Front is 8, back is 8. So actually, it's just one solution, right? And we are generating the others by reflection and rotation. So all the other 8 all the 7, including the first one, are generated by rotation, reflection, but actually it's just one unique solution of it. So does that make sense? Okay. So yeah, so that is it. So you all solved magic square. You all also know that we can generate 8 different equivalent combination by rotation and reflection. And now I will quickly move on to some interesting facts which you may find.
Okay, can we take a minute's break?
Yeah, we can take.
It's now 12 o'clock. So about half an hour has passed since we last saw the shadow. You can see how much the shadow has moved. Okay, it's 12 o'clock right now. Just see how much the shadow has moved if you are watching the shadow.
I will pause it at this slide. So should I also?
Yeah, you can also see the shadow, but you can tell the audience to be back in a minute. Okay,
so we'll join in a minute. And meanwhile, you can have a look at this slide on the screen. And there's also magic square, but it's 4x4. Okay.
Again, just go back.
Okay, so we are back. Just giving a few minutes for the audience to settle. Okay. Screen is full screen. Okay, so we are back. So this is a 4x4 grid, and as you can see, like if you add again the row, column, and the diagonal, you will get the sum as. Can someone do it?
What's the sum? Add up, add 4 numbers.
Yeah.
Yeah.
Sum of 4 digits. Yeah. So there's a 4x4 magic square, but it's little different. So that's what we are going to like discuss in this slide, but we'll not solve it. It will take much more time to like figure out how to solve it. 44, 34. Are you sure? Yeah, it's 34, right? Okay. So is it like all the row, all the column, and the diagonal are 34? That someone has to check. But you have to trust on me that there is a magic square. So it should be same. Okay. So again, if you make a grid of the first one, if you write it on a piece of paper and if you rotate it and if you reflect it, how many combinations you will get? 8, because square has an 8-fold symmetry. So you will again get 8 different combinations, right? And the interesting thing about those combination was you can come back to any of the combination by performing either rotation or reflection. So those were equivalent solutions. Just look at the bottom grid. The bottom grid is also 34. It is also by rearranging the same numbers. But now, if you observe this point, the 15 is here and 15 here is in the corner. So no matter how many times you rotate or reflect, you won't be able to achieve this combination. But it is still a magic square. So the same set of numbers, 1 to 16, can be rearranged in 2 different forms or 2 different magic squares, which are unique. Each of those could be rearranged again in either rotation, reflection, giving 8 different combinations. So 16 we can see here only, like 8 and 8. So is it clear so far? But can you guess how many different such unique magic square would be there for 4 cross 4? For 3 cross 3, how many combinations were there? Only one, right? For 3 cross 3, it was only one. For 4 cross 4, I'm showing 2 on the screen. But what is your guess? Like how many unique combinations would be there? 4, any number, 5, 6, 8. Okay, so actually it's 880. So 880 different solutions are possible. And yeah, so there is a lot of possibilities of figuring out what these solutions would be. The number of possibilities are also quite high, right? It's 16 factorial. So, and out of those, only 880 would be there. Okay, so this was a summary. 3 cross 3, 1, 4 cross 4, 880, 5 cross 5. So imagine a 5 cross 5 magic square, 1 to 25 numbers. You are rearranging those to make a grid. How many different unique squares are found so far? Any guesses? You can even guess the order of magnitude. Like lakhs, crores, thousands, 10 raised to 9. Okay. So how much is this? This is roughly 2.5 crores or 27?
27.
27. Okay, what about 6 cross 6?
So that was 10 raised to 9.
10 raised to 9, 6. Okay. So any guesses for 6 cross 6? So you have a grid of 36 numbers. You are rearranging to form magic square. How many distinct solutions are possible? Of course, humanly won't be possible to figure these out. So you need to write computer programs to like figure these combination or do some apply some statistical and computation techniques to figure out. But any guesses? 10 raised to 15, 10 raised to 27. Okay, so it's 18, and after 18 there are 18 zeros. So it is like these are many distinct squares, and that too we don't know. So it's an approximation, and so it's unsolved. No, it's unsolved. So after up to 5 cross 5, we know the distinct numbers of magic squares for the grid, but for 6 cross 6 onwards, it's approximation. Use statistical techniques to come up with a estimate, but like these are just estimation. Fine. So that was it from my end. We have one more game. So this is just a summary slides. We solved this into this, and we saw the rotation reflection, and we saw the final some interesting facts around magic squares. So we'll go back to the game. And if you all remember, I mentioned that in the first game, which you all played, there was one loophole. What is a loophole? Loophole is something which is there to make you win if you know the loophole. So perfect. So okay, so for all the so I will just share the screen, and we'll go back to that screen of this game, and this would perhaps make it clear. Okay, so what's the loophole? So if the player 1 puts 9 in the center, yes. Okay, so the loophole in this game was, so if the player 1 puts 9 in the center, so if you know the loophole, you go as a player 1, you put 9 in the center. No matter which number the player 2 will put in any of the grids, the player 1 is always going to win. Should we just look at it? Like 9 is in the center, which number you want to put? Okay, 10 in the top right. So player 1 can put 8 here. And if you put maybe again start with 9, you put any number in any place. And now seeing the pattern is so easy, right? And remember like how much concentration you all were like putting into like play that game in the beginning. It's the same grid. So once you start looking at the pattern, like you notice like some interesting okay. So but we can, there is a 17 below 9. Yep. So is there a way around for the loophole, because you want to make game also, right? So as a game designer, you can design your own game. So you can make it a rule that once the player 1 cannot make the first 2 as 9 in the center, and then you have the game as it is, like from the beginning. You just put one condition, and then you can replay the game. Okay. I have another one. This one is, for this one I may need a whiteboard. So we'll look at the slight variation of this game.
You want to play one more game?
If you all want to play one more game, okay. Stop sharing. First, I want to show the slides, and then I'll come back to the whiteboard. Yeah. Okay. So I will quickly just show a quick demo of the game. What is the objective, and then I will shift to the whiteboard because there is no way to annotate on the PPT. Okay. So this is a okay. So this is a game. So we have all the 9 numbers. The target sum is again 27. But imagine these to be cards. So you have a set of 9 cards. 2 players are like playing with each other. So you have to choose cards such that your set of cards should sum up to 27. So I can choose 1. The second player chooses, maybe I'm player 1. So I choose card as 10. Then the player 1 will choose 9. Then I choose 15. Player 1 chooses 2. I choose 16. So player 1 chooses 1. Now if I choose 8, okay. So right now I have how many cards? 10, 15, 16, and 8. And out of these cards, none of the combination could form 27, right? But in this case, if player 2 chooses 17, the first card which they choose and the third and the fourth card leads to sum as 27. So player 2 wins. So you have to block the opponent card at the same time, figuring out choosing such card from the set so that you get to form 27. Is the rule clear? We are not okay. So this is just the sum of 3 cards. Yeah, it has to be sum of 3 cards, but the order does not matter. Like it should not be like consecutive 3 cards. Any set of 3 cards which you have can sum up to 27. So that's the little variation in the game. So do you want to try it out? I can make we can go to the whiteboard and I'll put the answers there. Okay. So let's see. New share whiteboard. Is the whiteboard? It's visible. Okay.
Maybe you can explain the rules once again.
Okay, so maybe I'll first write just the numbers. So how many cards we have? So we have 1, 2,
Just write the numbers.
1, 2, 3, then 8, 9, 10. 15, 16, 17. Are you sure these were the numbers? And the target sum is 27. So this is all we need. The set of 9 cards. Okay, let's look at now the moves. So I will just put, there's little lag here. So, okay. So player 1 and this is player 2. So maybe we'll play with an offline audience and maybe online audience can just follow like what we are playing. Okay. And if there is any confusion in the rule, I will explain it once again. So who wants to go first? 2 volunteers again. Okay. Yeah. So 1 volunteer from this side. Okay. Yeah, you can choose the first card. Nee, it's fine. I think this is a different game. So is choosing 9, what do you think? Like is choosing 9 first will give unfair advantage to the player team 1? Do you think it will give unfair advantage? No. Okay. So we don't know, but let's see. So 9 is gone. Nine is chosen by player 1. And okay, the player 2 moves. Which card you want to pick? 16. So player 2 chooses 16. So I will cross 16 here. Okay. 8. So you all can guess like what should be the next move? 10. Why you are choosing 10?
But otherwise he'll choose it.
Yeah, otherwise he'll choose it and then 8, 9, 10 will form 27. So you have to block it. So there is no option. Why you are choosing 1? Because 16 and 10. Okay. 17. Okay, I'm just also cutting it. 1 is gone. 17 is gone.
10 is gone.
10 is gone. 8 is gone. Okay, we're left with 2, 3, 15. 3 numbers. 15. Okay. Why 3? Why 3? 15? 59, 3 would be at 27. So you're blocking it. Okay. So, and any of your cards, are you able to form 27 anyhow? No, right? Okay. Is it draw? It's a draw. So let's choose one. Let's see through it. 2. Okay. Yeah, only choice is 15. Acha, okay. 15 is good. Okay, so you understood the game. Of course, you can make it more complex by starting with a different set of 9 numbers, and that we haven't discussed. But as we have seen that in calendar, there are different set of 9 numbers which you can start as a combination to make magic square. You can also have negative numbers, and we'll see one example of a magic square with negative numbers. Do you want to play once again, or should I just discuss what is happening here in this using this as an example? Yeah, that okay. We'll go back to the earlier game with negative numbers, and then I think we'll end the session. Meanwhile, I'll just explain what is happening behind the scene in this game. Okay, so can someone just this is a too big a grid, so I have to make 2 grids. So bear with my handwriting. So I know it's not, it's hanging a lot. So, okay. We have finally 2 grids. So can someone suggest what was the magic square, the combination, which we finally figured out using these set of 9 numbers? 16, 3, 8, 1, 1, 9, 17. We all saw this, right? 10, 15, 15, 2. I will use a different color, purple. Okay. So now let's play tic-tac-toe. Okay. So what was players 1 move? 9. So whenever there is 9, so I will player 1. I will use cross. For player 2, I will use O. So what was players 2 move? 16. 16 is here. So I'm putting O here. What was player 1 second move? 8. Where is 8? So which move you have to place 10? Okay. What was the third move? 1. So you have to block it by 17. So are you able to follow? What you were actually doing is you were playing tic-tac-toe. Okay, let's look at 15. Where is 15? This is 15. And then 3. And then 2. Okay. So this was it from my end, but
see how easy it is to make games with numbers. And all it needs is adding 2 numbers. Simple. So go home and have this. I think this good. I don't know. The thing is, see this good. We have 9 numbers, right? And I made groups of 3, like first 3, middle 3, okay. And each group of 3, you notice there is a low, a middle, and a high. Okay. Now what I see is, if I choose 1 low, 1 middle, and 1 high, and you always get 27. Or every time, like just move the pattern. First, from the first group, let's do a low number. That's 1. Then I can see 1 middle and 1 high from the other group.
Okay.
So let's do high from the middle group. So the high from the middle group is 10.
Okay.
So I have chosen a low from high and now the middle from the third group, which is 16.
Okay.
And I get 27. So always 1 low, 1 high, 1 middle. You always get 27. Can you repeat that for the online audience?
Okay, so basically you're suggesting that if we choose 1 low, which is 1, which is okay, this okay, so we can bundle these 9 numbers into 3 different groups, and then we choose one low from the first group. Okay. 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 So for the third group, now we choose a middle number. So if we choose high, then from third group we choose a middle, and we'll get a combination. We always get 27. So again, this is an interesting pattern. So as we all can see, there are different ways to figure out those 9 numbers combination, And yeah, so if you spend some more time, you can figure out and make your own games, and you can think of different rules and different ways of making it more interesting and engaging. But I hope in today's session, I may be able to like enthuse you about like this idea of magic square and how vast this topic is. And even with so little and so simple addition and subtraction, we can have some interesting and beautiful patterns and even connections with tic-tac-toe as a game. Before ending today's session, I'll just show some more things for you all to explore if you are interested, and some references from where I draw the ideas, where I've drawn the ideas from. Okay, so yeah, so as you can see, like this was the negative number. So if you add the top magic square, you get the sum as 0. So you can have magic square with negative numbers, you can have magic square with fraction, you can have a multiplicative magic square, such that if you multiply these 3 numbers, you get a same product. So that becomes your multiplicative magic square, and you can make all the games. All you need to figure out a operation, which is addition or subtraction or division, whatever the operation could be, and set of 9 numbers, and your target sum. So target sum in our case was 27. Depending on your operation and the 9 set of numbers, you will have a different target sum, and you can create your own games. You can have magic squares with prime numbers. You can have magic squares with, yeah, it's limited by your own creativity, like what else we can think of. So here is an example of an artwork by a German artist like Albert Dürer's. It's a very famous magic square. There is this painting, engraving called Melancholia. It's of the year 1514. And if you see on the top right, there is an engraving on this wall. And this engraving is the same as this magic square, which we just saw 4 cross 4 1. So I've just highlighted this engraving here. It has a historical significance associated with it. You can read up more about that using this artwork. But the interesting thing here is that you can see the air being engraved in the bottom, and it's a magic square. So 1514, this was there, and I again didn't recall everything. All the information which I presented was there on the screen. So again, you see that it, and some people also say that Albert Dürer was his initials, right? So 1 and 4. So 4 and 1 is also there in the bottom row. So you can have like different numbers to choose from and make your own magic square. These are some of the references, and the Hindi version of this talk I gave like sometime back last month on HBCC channel. So I would also like to acknowledge a lot of members who gave feedback for the talk. So any questions and queries, you can mail it to me. And yeah, thank you.
Thank you. If there are any questions, we can take them. Otherwise, it's exactly 25, 10 more minutes. We should go outside. Let me first say thank you. Thank you, Ravi. Thanks, audience. Thank you. This was, I think it's amazing how just with simple numbers, addition, subtraction, you can have so much fun. And I don't think all of us thought that we've played tic-tac-toe so many times. But here are all variations of that game. You look at a calendar so many times, you don't realize that any block of numbers there, you can make a magic square out of it. So there are so many connections to everyday life, the games we play, etc. And you can invent your own game. This is the fun of it. So I hope you had fun. If you have questions about Chai and Why, please send us an email. It's outreach, outreach @tifr.res.in. And remember, 2 weeks from now, we'll be back at Rupal College with again a hands-on session looking at games and problems from the world of computer science, looking at networks and graphs. And the first Sunday of June, we will be having biology experiments at Prithvi Theatre. So on that note, thanks for watching and see you later. Of course, the in-person audience is welcome to go outside and take part in the next thing, which is the Zero Shadow Day activities. Bye for now.